Greetings to respected Madam Sirs. This is Pavan Sai from Computer Science, Artificial Intelligence and Machine Learning from the section C. So, today I'll be talking about problem solving essential, and my topic is regarding isomorphism in graph theory methods and algorithm. Well, graph isomorphism is a key concept. In the graph theory, it plays a role in solving compensation in a real world problems. So, essential of problem solving is based on problem solving, which is also helps in the foundation of mathematics and computer science and engineering. The key elements of this are understanding problems like breaking it down, choosing the right methods, implementation, and verifying the solution. So, let's get into my presentation. So, this is the introduction regarding my topic isomorphism in graph theory. So here the introduction begins with the presentation which explores through the graph theory which mainly focuses on definitions like types of methods to identify them and their applications. So basics of isomorphisms. So definition of isomorphisms are mapping between two graphs and preserve the structure of edge and vertices. Two graphs are isomorphic if the exists of bijunction between their vertex sets the preserves adjacency. So types of isomorphism in graph. So there are very various types of isotomic, including strict isomorphism, while requiring extra structure, preservation of weak isomorphism, which allows certain transformations which maintain connectivity and based on its properties. The ISO importance of graph theory. So basic needs are like understanding isomorphisms in a crucial in graph theory as it helps in classifying graphs, determining the equivalence and solving the problems like network designing and optimization. And the graph representation. So why is this important? Using in chemistry, modular structures like in software fields like network security, database indexing, and artificial intelligence. Basically, it helps in patterns and recognize and detect the structural surfaces in data. So methods for checking graph isomorphism are adjacency matrix comparison and degree sequence matching and canonical labeling graph invariance. So algorithms for graph isotomics are Naughty algorithm. Also, it is a well-known method to find canonical labels of graphs. So, and the next one is Westphal-Lehman algorithm, which is used in machine learning for graphic-based tasks. Babai's Quai's polymal algorithm, which was found in 2019. Basically, it's a breakthrough in improving efficiency for solving the graph isomorphic problems. And the adjacency lists. Adjacency lists represent a graph as a collection of lists. Each vertex has a list of advancement vertices, making them representation affect spatial graphs in terms of space. And the adjacency of matrices. An adjacency matrices is a square pattern used to represent a graph. The entities indicates whether pairs of vertices are adjacent. It particularly is useful for dense graphs which occur when connections are numericals. So incidence of matrices. An incidence matrix represents the relation between edge and vertices in the graph shown which vertices are connected by the edge. It is particularly useful in applications involving biparallel graphs. Methods for identifying isotomism. Naive algorithms. Naive algorithms for graph isomorphism involves in exhausting search methods, comparing all possibilities mapping between the vertices sets of two graphs. Despite being simple to implement, they are computationally expensive and impractical for large graphs. Canonical forms. Canonical forms refer to standardized representation of graphs that allows for easy comparison by transforming graph into a unique form. It becomes simple to determine isotomic by checking if the graph shares the same canonical form. In the subgrading isomorphism techniques. So subgrading isomorphism techniques are focusing on finding incidence of a small subgraph with uh, within a large graph. These methods have applications in numerical fields, including biology and social network analysis, where substructure identification is crucial. So algorithm and complexity, graph isotomic isomorphism problems. These problems are seek to determine if two finite graphs are isotomic. The problems is notable because it is neither known to be solvable in polynomial time nor proven to be complete, making it a unique subject of study in theory computer science. So polynomial time algorithms, which research into polynomial time algorithm for graphs isomorphism has yielded significant advancements, with the most notable being the Laszlo-Babai algorithm, which operates a quasi-polynomial times and represents a major breakthrough in the field. So NP-complete problems. Certain instances of the graph isotomic problems can be reduced to NP-complete problems, highlighting the relation in crucial for developing the better algorithm. The applications of isomorphism are network analysis. In network analysis, isomorphisms helps identifying similar network structures, assess connectivity and optimal pathway. Applications including social network, transformations networks, and communicational networks, where patterns can be informed strategical decisions. So chemistry and modular graphs. In chemistry, modular structures can be represented as graph isotomic. This plays a key role in determining if two different representations refer to the same modular structure, aiding in drugs discovery and material science. So computer science applications. In computer science, graph isomorphisms are fundamental in various domains, individual database theory, algorithms, and designs and computational biology. This helps in pattern recognition resources, which allocates the software optimization. And the conclusion, the study of isotomic graph theory is foundation with significant implementations across the various fields. Understanding their methods, complexity and applications can be informed advancements in technologies and science. So also the problem solving requires logical thinking, structure methods and effective algorithms. The graph isotomic is a key challenge in graph theory with applications in various fields. Understanding the different methods and algorithms can help in solving real-time problems effectively. And we can also check that the essential of problem solving, basically it identifies the problem clearing, defining and questions and challenging, breaking down into problems, decomposes into smaller, more manageable steps, choosing the right approaches, self is suitable mathematical algorithm, heuristic movements, applying an effective algorithm, ensuring the chosen methods in the optimal in terms of space complexing, evaluating and optimizing the solution, verifying the correcting and improving effectively. Problem solving in graph theory. This is regarding the subject. So graph theory simplifies complex problems in networking, scheduling, data structures, and artificial intelligence by representing them and a node and edge. Graph isotomics theory. Basically, I want to define it with one point and one example. So the two graphs are isotomic if there is one-to-one corresponding between them vertically and edge, while preventing adjacence. See, and the example I want to provide is differential representations of the same network technology in computer science or molecular structure in chemistry. Why graph theory isotopes or matters is using in patterns recognize image processing, bioformatting for and cryptography and social network analysis. And I want to conclude my presentation with this. Thank you.